Good morning. The line as a locus, problem set 37, and the midpoint formula. These aren't difficult, guys, okay? The line as a locus, locus just means place in Latin, okay? So where we get the word location from. This just involves two separate distance formulas set equal to each other, and then you solve for y. Two separate distance formulas that are set equal to each other, then you solve for y. So let's start with that. Now, the line as a locus, this is what I want to explain to you guys. If you have 2 points out in space in the middle of your Cartesian coordinate system, okay, and you want to find the line where every single point on that line is exactly the same distance between this point and the line and this point and the line. That's the line you're looking for. This is the way to do it. So for these 2 points, which I randomly put on here, probably the line that is exactly equidistant from every single point on there is probably there. Something like that. So look, this point is exactly that far from that point, and also that far from that point. It's the same distance. The distances are equal. Now what about, I don't know, this point on the line? Well, look, that distance is the exact same distance as that distance, and so on. Let's do one more. This point on the line is exactly the same distance from here to here as it is from here to here. So you are tasked, when you're given 2 points, you have to find the equation of this line that is exactly equivalent distance from all of those points. And look, I made a nice little kite. I want to fly outside. Look at that. I haven't been outside in a month and a half, guys. You got to rescue me. I got to get out. Ooh, it's terrible. All right, we'll get back. Keep hope. Let me explain how this works then. Gonna have to go this way for this one. So look, the distance formula, if you remember, it's the square root of y2. Oh, here it is. Square root of, I always put the y's first. y2 minus y1 squared plus x2 minus x1 squared. Or as long as you're consistent, you're fine. So let's look at this problem. Find the equation of the line, top of page 264, that is equidistant from the points 4, 2, and negative 2, negative 3. 4, 2, negative 2, negative 3. Okay, so just a quick little graph here. 4, 2 is about here, and negative 2, negative 3 is about here. So the line that goes, it's probably something like that. That's the line we're looking for. So we're going to, this is the point 4, 2. This is the point negative 2, negative 3. So any point on the line is what we're looking for that is equidistant. This point, this imaginary point, this random point that we're choosing, we're going to label as xy. So we need to do the distance formula for these 2 points and set it equal to the distance formula for these 2 points, okay? So there's my point on the line. Here are my 2 points out in space. So let's, I'm not even going to use the square root symbol, even though that's part of the distance formula, because we're going to use the square root on both sides, and then we're just going to square it anyway. As you'll see, look, the square root is there. The first step is to square both sides to get rid of the square roots. So I'm not even going to put it down, okay? All right, so let's call this our first point and this our second point. We're going to do these 2 points first and set them equal to the other ones. So y2, which is y, minus y1, which is 2, squared, plus x2, which is x, minus x1, which is 4, squared. Now that has to equal, usually you'd have a square root, but since the first step is just to square it anyway, I'm not even going to put it down, all right? Now we're going to do these 2 points. y2, because that's the point on the line we're talking about. We're trying to get the distances equal. This distance is equal to this distance. So y2, which is y, minus y1, which is negative 3, minus negative 3, squared, plus x2 minus x1, negative 2, squared. I set them equal to each other. Now we have to, now we got to FOIL all of these things, all right? So y minus 2 squared, that is y squared minus 2y minus 2y, which is minus 4y, and then negative 2 times negative 2 is plus 4, plus x times x, x squared, negative 4x, that's negative 8x, and then negative 4 times negative 4 is positive 16, equals y squared. This is going to be a negative is a positive. So 3y plus 3y is 6y. And then 3 times 3 is 9. Plus x times x, x squared. And then a negative 2 is positive 2, right? So 2x and 2x is 4x. And then 2 times 2 is 4. Okay, so you get this big, long, crazy equation. Well, look, you have, this should be y squared. You have y squareds on each side, so you can subtract those from each side. You have x squareds on each side, so you can subtract those. That'll leave you on this side with negative 4y, and then 4 plus 16 is 20, right? And then negative 8x equals, let's simplify this side, 6y, 9 plus 4 is 13, and then plus 4x. Now, fellas, all you got to do is solve for y. So I'm going to bring negative 6y this way, negative 6y, to get y's on one side. That's negative 10y. Whoop. Subtract 20. Subtract 20. So that's negative 7 over here, right? And then I'm going to add 8x. That gives me 12x. Okay, everyone with me so far? Now to solve for y, because we're looking for this line right here. It should be going downhill, and the y-intercept looks to be close to 0, right? So divide everything by negative 10. Which means these cancel, so you get y equals 12 over negative 10 is negative 6 fifths x, and negative 7 over negative 10 is plus 7 tenths. So it's somewhere around 0. I mean, it's not an exact graph, right? This is the line, okay, that is exactly, any point on the line is exactly equal to any point, these 2 points up here. So this point, any point, whoop, exactly equal to this point here. Exactly equal. This is the line. So you pick a random point, we call it xy on the line, and then we have these 2 other points. We do the distance formula for these 2, then we do the distance formula for these 2, set them equal to each other. Then we have to FOIL them out. Got to zoom out so you can see how, this big long equation. Cancel the x squareds and the y squareds. Then you get Then you solve for y. Y is alone on one side, everything else alone on the other. Okay, so that's the line as a locus, and I'll upload another video for the midpoint formula.